Hello everyone, welcome to In 5 Minutes. In this video we will see one sum based on Butterworth filter. Let us see the question. The question states that we have to find out the order and cutoff frequency of digital filter with these specifications. The specifications are as follows. H of e raised to j omega, that should be less than or equal to 1 or greater than or equal to 0.8. Now you should see that these values mean something. This value is AP, as we can prove this from characteristic plot, and also this range is for omega p, that is a passband value, and here h of e raised to j omega should be less than or equal to 0.18. Now this value should be as, and this value should be the stop band. Now we also have to draw its poles. So these are the specifications given as AP, AS, omega p and omega s. But first, let us calculate the order of the filter. The order of the filter is given by capital N is equal to half log of 1 upon AS square minus 1 divided by 1 upon AP square minus 1, the whole divided by log of omega s upon omega p. Now first we will obtain these values, that is omega s and omega p. That will be omega p is equal to omega p upon ts and omega s is equal to omega s upon ts. Now as this is an impulse invariance method, we will use these formulas. Now in this case, sampling time is not given. So we will assume that ts is equal to 1 second. Now as ts is equal to 1 second, obviously omega p is equal to omega p and this is equal to this. Now you will see that it is equal to 0.4 pi and this is equal to 0.6 pi. Now we can easily find out the values of capital N, that is the order of the filter. Let us solve that. Capital N is equal to half log of 1 upon 0.18 the whole square minus 1 upon 1 upon 0.89 the whole square minus 1 divided by log of 0.6 pi upon 0.4 pi equal to half into 2.056 upon 0.176, that will give us 5.83. So 5.83 is generally tending to 6, so capital N is equal to 6. Now this is a sixth order filter. First we will calculate the cutoff frequency. The cutoff frequency is given as omega c is equal to omega p upon 1 upon AP square minus 1 into 1 by 2n, that is equal to 0.4 pi upon 1 upon 0.89 the whole square minus 1 raised to 1 upon 2 into 6. 1 upon 2 into 6 gives 1 by 12. Now we will calculate these terms and we finally get omega c is equal to 1.405. Now we have calculated the cutoff frequency as well as the order. Next we go for the calculation of the poles. The calculation of the poles is given by pk is equal to plus minus omega c e raised to j n plus 2k plus 1 pi divided by 2n. Now your k ranges from 0 to n minus 1. Thus your n is equal to 6. So we have k ranging from 0 to 5. So first case, that is k is equal to 0. When k is equal to 0, p0 is equal to plus minus 1.405 e raised to j 6 plus 0 plus 1, that is 7 raised to pi by 12. Now this will give us plus minus 1.405 e raised to j 7 pi by 12. Now expanding this term as cos 7 pi by 12 plus j sin 7 pi by 12, we finally get plus minus 1.405 minus 0.26 plus j 0.97. So we get p0 as minus 0.37 plus j 1.37 comma 0.37 minus j 1.37. This is for the k is equal to 0. Now let us see for k is equal to 1.